Hi! Today we are going to discuss about population rate. What is population rate? Population growth is the rate of increase in the number of individuals as in a population in a given time period. Let's take a look at an example from population rate problem. So here's one. For population problems, all the ways for a population to enter the region are included in the entering rate. Birth rate and migration into the region are examples of terms that would go into the rate at which the population enters the region.
Here's an example. A population of insects in a region will grow at a rate that is proportional to their current population. In the absence of any outside factors, the population will triple in 2 weeks' time. On any given day, there is a net migration into the area of 15 insects and 16 are eaten by the local bird population and 7 die of natural causes. If there are initially 100 insects in the area, will the population survive? If not, when do they die out? And now, here's the solution. Let's start out by looking at the birth rate. We are told that the insects will be born at a rate that is proportional to the current population. This means that the birth rate can be written as RP. Note that in the first line we use parentheses to note which terms went into which parts of the differential equation. Also note that we don't make use of the fact that the population will triple in 2 weeks' time in the absence of outside factors here. In the absence of outside factors mean that the only things that we can consider is birth rate. Nothing else can enter into the picture and clearly we have other influence in the differential equation. Well, we should also note that without knowing R, we will have difficult time to solving the additive completely.
Okay, back to the differential equation that ignores all the outside factors. This differential equation is separable and linear and is a simple differential equation to solve. We will leave the detail to get the general solution. Applying the initial condition give C equals to 100. Now, apply the second condition. We need to solve this for R. First, divide both sides by 100. Then, take the natural log of both sides. We made use of the fact that here to simplify the problem. Now that we have R, we can go back and solve the original differential equation. We will rewrite it a little for the solution process.
This is a very simple linear differential equation, but that coefficient of P always gets triple bent out of shape. So we'll go through at least some of the details here. Now, don't get excited about the integrating factor here. It's just like e to t, only this time the constant is a little more complicated than just a 2, but it is a constant. Now solve the differential equation. Again, do not get excited about doing the right-hand integral. It's just like integrating e to t. Applying the initial condition gives the following equation. Now the exponential has a positive exponent and so will go to plus infinity as t increases. Clearly, population can't be negative, but in order for the population to go negative, it must pass through 0. In other words, eventually all the insects must die, so they don't survive, and we can solve the following to determine when they die out. So the insect will survive for around 7.2 weeks. Here is a graph of the population during the time in which they survive. The end. Thank you.
created using Powtoon.